Okay. So before we talking about the fundamentals of UML or the Unified Modeling Language, so let's recap what we have done so far. So we had uh, the discussion about how the software complexity is happening. So we have understand various reasons of software complexity, and then we have discussed about how to manage these complexity. So basically we have figured out we can do the decomposition. So in the decomposition we have two different techniques called algorithmic and the object oriented decompositions, and then we have discussed about the characteristics of objects, and also we have covered the some sort of very brief introduction of the class. And then we have discussed about the programming paradigm. So it's basically procedural paradigm and object-oriented paradigm. And then you have one activity to submit. Uh, so I think it's today, right? And then you have the first task of the guided project. So I will not conducting the tutorial sessions today. So you can take that 1 hour time and complete these two tasks and send me. So these are not hard tasks. So as the introduction to the UML or the Unified Modeling Language, so there is a need of having some sort of expressive language. So the people wanted to communicate at different highly technical aspects to non-technical people like end users. So in that case, using technical jargons, codes were not a good solution. Using those kind of things were not good solution because the clients do not have that much higher level of technical understanding. So that's why people wanted some sort of standard set of notations, right? So when it comes to electronics, so we have the circuit diagram symbols. So we know LEDs having a standard notation. So that particular notation is used in Sri Lanka, USA, China, etc. That's not going to change. So likewise, for the software development, people want standard language. So the unified language, what UML came as a result of that need, right? And then it's some sort of primary modeling language. Basically, this UML is used to analyze, specify, and design the software system. And also, UML is an industry standard graphical language to specify, visualize, construct, and document the uh, different artifacts of the software system. So we have two versions so far, 1 and 2. So the wordings of UML or the Unified Modeling Language, so the meaning of the unified means it's a single model. So we can apply to almost all the phases of the software development life cycle. So the UML is mainly supporting these object-oriented concepts. So it means it supports object-oriented decomposition and the object-oriented programming paradigm. So UML is some sort of blended approach of uh, object-oriented concepts, right? So and then we have the word modeling. So the modeling is represent the main activity of this UML. So it basically This UML is used to represent a very simplified view of reality in order to facilitate the design and the implementation of the object-oriented software system. So it's some sort of modeling language that used to develop design documents. Right, that's why we have this modeling keyword and then the language. So it's a graphical language that had set of standard notations and it is recognized worldwide, and also it's controlled. I mean the version controlling or the standardization is done by the OMG or the object management group. So it's a combination of components. So the need of UML for modeling. So first thing is using the graphical notation to communicate is very much easy when it comes to the communication, right? So the clients are usually non-technical people, but the development team is having technical expertise. So in that case, if clients, if development team is communicating with so many technical jargons, client will not understand anything. And also vice versa. So in order to overcome these communication issues, UML suggests the standard graphical notations. And since it is representing the modeling part of the design section of mainly design section of the overall system, so we can have an overall view of the system. And also UML is independent language. It's not dependent on any sort of language or technology. So it's basically UML move us from the fragmentation to the standardization. So we will learn different UML design based on the different requirements. So we have another before we going to the what we call UML concepts. So we have a diagram taxonomy. So the diagram taxonomy is some sort of concept related to diagrams. So we know, so we have the discussion of in the first session, and also we have discussed the same thing somewhat advanced level in the second session also. So we have talked about the system complexity. So we know the system complexity can be driven or can be created from the system structure or the number of the number and the organization of the system components or the elements. So the structure is the way of organization of the elements in the system and also the count of these elements. So and then system complexity also can be driven from the system behavior. So the system behaviors mean the functions or the communications or the interaction of these system elements. So basically system complexity we can driven from the structure and the behavior. Since the complexity is having two sources, also the UML diagrams have developed into two categories. So we have structure diagrams and the behavior diagrams. So now you can see the UML is originally designed to reduce the design issues, right? Because the software complexity has two sources, basically structure and the behavior. So these are mainly started from the designing section or the components organizing of the components and the interaction, right? So that's why UML have two different design diagram categories, structure diagrams and the behavior diagrams, right? So when it comes to behavior diagram, so we know behavior is nothing but the interactions between or the inside of the element, right? So when it comes to the software system, so there are so many objects created and these objects are destroyed, and these objects are sending so many messages, and also there are so many triggers, external factors that affecting to these objects also. So the behavior diagrams is focusing design of these object creation, destroy, different object messages, etc. Right? So we have different set of UML diagrams to describe, which is able to describe the behavior of the system. So we have use case, activity, state machine. So we have another set of diagrams. It's basically the interaction diagram. So under the interaction diagram, so we have sequence, communication, interaction overview, and the timing diagram. When it comes to the structure diagrams, so we basically try to represent the structure of the elements in the system. Usually, this covers the architecture of the system and how the physical elements placed in the system, and in some cases, different runtime or network or whatever related configurations, and then the domain specific elements. So under the structure diagrams, we have package, class, component, deployment, object, and composite structure diagrams. So as the big picture, so this is the UML diagrams is here, and we have two categories: structural diagrams and the behavior diagrams. And in the structural diagrams, we will have package, class, component, deployment, object, composite structure. And then when it comes to the behavior diagrams, so we have use case, activity, state machine, and in as the interaction diagrams, we have sequence, communication, interaction overview, and timing diagrams. Okay. So, and like I have created a set of slides about each and every diagram. So I'm not focusing. I'm like for your information, I have added those slides so you can read by yourselves, because we will go through each and every diagram deep way, right? So first thing is the use case diagram. So this is a very simple explanation of use case diagrams. And if we see the diagram, so this is something like this. So you can see users are there. So that's why it name came from the use case, etc. Right? And we have the activity diagrams. So this is it. And this is the state machine diagrams. Okay, so since like you are engineering students, so you are familiar with this diagram also. And also we have different interaction diagrams. So the sequence diagram will be something like this, and you will be learning how to develop the standard sequence diagram. And we have the communication diagram. So this is the communication diagram, and we have the interaction overview diagram. So basically this interaction diagram is a combination of activity diagram and sequence diagram. So you can see the upper part of the diagram is activity diagram where this letter part is the sequence done. And we have the timing diagram. So when it comes to structural diagrams, we have the component diagram, so it's very easy, right? So basically, these kind of diagrams will have if there is so many sensors and hardware components. And then we have the package diagram. So the package diagram is basically something that deal with object-oriented concepts. Anyway, each and every design, these UML diagrams are dealing with object-oriented concepts, right? And then we have the class diagram. So this is some very simple example for the class diagram. And we have the option diagrams. So the composite structure diagram, it's also something like this. And the deployment diagram. So the deployment diagrams will be usually used to when the system implementation of the deploy is there. So where it's the particular system is hosted and how the what are the layers of the deployment, etc. There will be graphically represented. So we go back to the big picture. Yeah. So for your syllabus, we have use case, activity, state machine, and sequence diagrams as the behavior diagrams. And in the structural diagrams, you only have this class diagram. So then your lives are much easier. So do you have any question? Okay. So that's all for today's session. So this week, I won't conduct the tutorial, but you can take that 1 hour time to complete the activity, given activity and the task one of the guided project. And next week onwards, we will start drawing these UML diagrams. So it will we will have around 7 diagrams to be practice. So in that case, I will take the tutorial session also, and make sure you are participating to that sessions, right? So because that 7 weeks will be the only tutorial, only sessions that we have the tutorial and the most important part of the entire module. So yeah, thank you very much.
Thank you, Miss.